So now we're moving on to lesson 8, which is friction. So definition of friction, when we draw a free body diagram, we have already talked about that is basically forces that are opposing or impeding the start of it. It's always between two surfaces in contact. And one thing we really haven't talked about is the friction can not only be in solid, it also happens in liquid and gases. So situation where it could be adventurous. So why don't you write this down, right? Take a moment and think. When do you want more friction and when do you not want more friction, right? This could be a very good application question on the test. So pause the video, write out. When do you want friction and when do you want to not have so much friction? So some of the examples that I can think of, we want to decrease friction probably in like competitive sport. Or other things could be like to reduce the heat for like engine or something like that, right? Like because when we go to unit 3, talking about energy, a lot of mechanical energies are lost just basically by friction and turning into heat, right? So those are the things we don't want. But then you also can't live without frictions. You definitely want to increase friction if it's very slippery outside. Like when you're driving in the snow, you want it to increase the friction. And other situation, it even if you wanted to start moving, can you imagine you starting to walk, but if there's no friction? You want to turn a doorknob if there is no frictions, right? It is actually something that's very essential to everyday function, right? To, for example, starting to walk. Or like I can't list all of it, right? Can you even drive without friction? I don't know. You can't. Your car won't start. You can't even grip the steering wheel. You can't do anything if there isn't friction, right? So there are situations that you have to have frictions. Okay, 2 types of friction. Static friction, when something is not moving yet, stationary, and friction is preventing it from starting to move. Kinetic frictions, FK, it's when something is already moving but it slows it down, so it's opposing the motion. And we use this symbol mu, this little U looking thing with a long tail. We call it the coefficient of frictions. And the equation for friction is FF equals mu Fn. Okay, FF is the force of friction, is measured in newtons. And then Fn is force of normal, also measured in newtons. So one thing just to address is that if I rearrange the equation for mu is Ff over Fn. And if they're both measured in newton, you need to know that mu, it actually has no unit. Okay, it's unitless because the thing cancel. And for different things, they have different value, like between, say, rubber and asphalt. When you're driving on a regular day road, mu worked out to be a certain number. But say wheels, plastic wheels on, say, icy surface, your contacting surface will change, and therefore the mu quantity would change as well. Okay, so there is data table that I don't expect you to remember what the number is. Sometimes I might require you to calculate what it is. And we would also tell you, what surface to what surface, and then you can also look it up in the textbook, page 81, table number 1. Okay, so this is called the coefficient of friction. Okay, your little sister wants to ride on a sled. If you're on the flat ground and will you exert less force if you push or pull her, assuming the same angle on each case? So they're saying, if I have a girl and you are pulling or pushing. So if this is pulling, your FA goes like that. Okay? If you're pushing, your FA goes like that. Okay? And they're saying that it's on the same angle. So angle theta is the same for both cases. Okay? We are so used to drawing free body diagram. Do you understand that this is the pulling and this is the pushing from the picture? Okay, keep in mind that we have been drawing free body diagram with the forces stemming from the middle. So I'm just gonna change for the pushing guy, I'm going to change the FA down here. Okay, it's still the same angle. Do you understand how that is still pushing? I just wanted to analyze the forces with the force coming all stemming from the middle of your free body diagram, because that's how we're used to be analyzing it. Okay, so those are what we're looking at. So what are we trying to get at? We are trying to understand the forces. Force of friction oppose motion, and they're basically trying to ask you to see what happened if I change the Fn. What happened if I change how quote unquote heavy something is or how light something is? Okay, that's what this question is talking about. So you are actually trying to find out what is the Fn. Okay, because what happened is the bigger the Fn, the bigger the force of friction will be, because they're proportional to each other, right? Because we know that Ff is mu times Fn for the same surface. If this goes up, this goes up. So if I have a bigger Fn, then it would be more difficult for me to move it. So it will require me more force. Okay. All right. So let's study and analyze it. Okay. So right now, the object is traveling to the right. It didn't tell you if it's accelerating or not, so I'm going to assume that it's accelerating going towards the right. We're going to analyze the force along the x and the y. Let's take a look at the y. I have force of gravity in both cases, and I have force of normal in both cases because the wagon is sitting on the ground. And I have to break my apply force into component, the x and y component. Okay, the y component for this force, because it's opposite to angle theta, this is Fa sine of theta. This is Fa cos of theta. Same thing. On the other situation, I have x and y. So the y that is going downwards is Fa sine theta and Fa cos theta. Okay, let's analyze the forces along y. So my first question for you is, the object is accelerating to the right. What is the acceleration along y? Okay, so what is the acceleration along y? That's my question for you. Can you write it down? What do you think it is? Acceleration along y. Okay. No acceleration along y because the object is traveling horizontally. It's on a flat ground. You're not accelerating up and down. So basically, you are trying to say that F net equals to ma, but a is 0 along the y direction for both cases. Okay, so what is the F net? Let's take a look at the pull situation. Two forces going up, one force going down. So I'm going to go up minus down. When there is no acceleration, remember, I think this is the 28th time that I've been saying it. If there is no acceleration, it doesn't matter if you say up or down as positive, right? Okay, so I'm just going to go up minus down. Up is Fn. Up is Fa sine theta. Down is Fg, and it equals to 0. So what does Fn equals to? Move the Fg to the other side, it becomes Fg. Move the Fa sine theta to the other side, it becomes minus. Okay, I'm just going to change this. Normally, in most situations, your Fn equals to Fg if the object is just sitting. This is how heavy you feel when you're just sitting there. But when you're pulling upwards, how heavy does it feel? The Fn, it's actually going to be smaller because you're subtracting whatever the upward force that you're applying to the sled. Let's study the other one. How about when you're pushing downwards? Okay, when you're pushing, F net equals to 0. What's F net? I got up, down, and down. So up force minus down force minus down force. Rearrange the equation for Fn. Fn is Fg become positive, adding Fa sine theta. So what that means is this will actually make it feel lighter, and this will actually make it feel heavier. And when something feels lighter, you're gonna have you just have to exert less force. So this will be less force. And if something is heavier, you're gonna have to exert more force. And the reason for that is because we talked about that already. F is proportional to Fn. And if Fn goes up, force of friction would increase, making it harder for you to push. So, number one, for this question, you need to understand that if a force is on an angle, you need to break it into the xy components, just like you've been doing for any first law questions. Second thing that I have really needed you to keep in mind is that not all Fn equals Fg. When you were doing these types of questions in grade 11, I want to say 99.99% of the question, you've been assuming Fn equals to Fg. Okay, so this is something I really need you to keep in mind. Okay, Fn not always equals Fg. All right, so just keep that in mind. Okay, anything that is on an inclined plane already, your Fn does not equal to Fg. And if you have any forces pushing downward, upwards, all those things will change your Fn as well. So keep that in mind. So that means it's important that you would still go ahead and solve the y components so that it will help you figure out what the FF is. Okay, Figaro. All right, read the question. Figaro the cat, which is 2 kilograms, is hanging on a tablecloth. So he's hanging, so we're dealing with Ft. We got a fish bowl that is 1K towards the edge of the table. The coefficient of kinetic friction between the tablecloth and the table is 0.44. What is the acceleration of Figaro and the fish bowl? Okay, we all love Figaro the cat. We got a cat. Okay, Figaro the cat is hanging onto a tablecloth. And there is a fish bowl, so there is a table. And there is a fish bowl. Okay, sitting on it. And basically, your tablecloth acts like a pulley question. Okay, so you have a pulley, almost like a pulley. This is where your tablecloth is. And you got a cat. Okay, the cat, it's 2K, and the fishbowl is 1. And it does have friction between the tablecloth and the table. Okay, so there is friction. So let's draw pictures. Okay, I'm going to call this mass 1. I'm going to call this mass 2. Okay, mass 1 is the cat. Okay, and he is 2K. So this is Figaro. And Figaro, so I do the same thing as pulleys. Figaro has a downward Fg. It's being hung up by the tablecloth, which is your Ft. Direction of acceleration is going to be down. That's the only thing it can do. The most that it can do is they don't move at all. If there's enough friction, you actually can't start to move the system. But if there's enough, if the friction is not too big, and then you could be accelerating, and it has to be going down. There's no way that the fish can go back to the other way. Just common sense. That's what I need. Okay, write my net force. So Fg minus Ft equals to Ma. Expand out the equation for Fg. Fg equals to mg. And the mass for Figaro, the cat, is 2 minus Ft equals 2 times A. So clean it up, multiply it out. And that looks like that's the most that we can go. We don't know Ft, we don't know A, so we're going to stop. Okay, then we're going to do the second block. Second one is the bowl. Mass 2 is 1. And this time, it is going sideways and sitting on a table. So I have Fg and Fn. There is a rope tying on the right hand side of the bowl. So I have Ft. And this time, when they give you coefficient of static friction, you know that it does have friction. We've been dealing with it like, oh, assume there's no friction or something like that. So this one has a friction. So I have FF. So the acceleration now, so we draw a free body diagram, we assume the direction of acceleration, it's going to be going towards the right. Okay, so to study the forces, I have along X, there's going to be two directions. There's the X direction and the Y directions. The X direction, it's going towards the right, so it's going to be right minus left. Ft minus Ff equals to Ma. I don't know what Ft is. I can calculate what is Ff. So we know that the equation, I'm gonna write everything out just to make sure we're good. I know that Ff is equals to mu times Fn. Goes into the Ff, so Ft minus mu Fn is equals to Ma. I don't know what Fn is, but I can find Fn by doing the y direction, kind of similar to what we were doing from the last question. You can figure out what is the Ff. So keep in mind, acceleration along y is 0. When there's x and y direction, at least one of them has to be 0. Okay, so in that case, I'm going to go up minus down equals to Ma, which is 0. So Fn have to equals to Fg, and I know that Fg is m times g, so the mass is 1. G is 9.8, so I get that Fn is equals to 9.8. So now I can sub that into this Fn. So Ft minus, I do know mu. They gave it to me in the question. Mu is 0.44. Mu means coefficient of friction, right? Times the Fn that I've calculated it to be 9.8 equals to the mass times the acceleration. Clean it up. Ft minus, so I took 0.44 multiplied by 9.8, so 4.312 equals to 1 times A is just A. Now, I have two equations with two unknown. You sub one into another, so it's up to you how you want to do it. I already have an isolation of A, so you really could sub the A into this A right here. This one blue. So I have 19.6 minus Ft equals to 2 times whatever A equal to. A is Ft minus 4.312, close the bracket. So I've substituted A from the other equation, and then because this is a bracket, I have to expand it out. So 19.6 minus Ft equals to 2Ft minus 2 multiplied by 4.312. Collect the like terms, bring all the t's to one side and all the numbers to the other side. So I'm going to bring, this is a minus, I'm going to bring that over, it becomes a plus. This is also a minus, I'm going to bring all the way over and it becomes a plus. I'm just gathering the like terms. So 19.6 adding 8.624 equals 2Ft adding Ft, so 3Ft on the right hand side, and then I'm going to gather up everything on the left hand side, add the 2, 28.224, so Ft worked out. Okay, now that we found Ft, we can now solve for A. So put Ft back into one of the equations. So this looks easy enough. I'm going to plug it back into that equation to solve for what A is. So A is going to be Ft minus 4.312, and Ft was 9.4 minus 4.312. The answer worked out to be 5.1 meters per second square. So they want you to know the acceleration of the Gara and the ball. So both are going at different directions, so I don't have to write a direction. Okay, a boy pulls a 50-kilogram crate across a level floor with a force of 200 newtons. If the force acts at an angle 30 degrees above the horizontal and the coefficient of kinetic friction is 3, determine what is the normal force exerted on the crate by the floor, what is the frictional force, what is the horizontal force, and the acceleration. So it didn't say in this question. I'm asking you to please assume that this one has 2 significant digits. Okay, so draw your free body diagram first. So I got it's being pulled at an angle. So it's pulling. So it's being pulled at an angle of 30 degrees. And at a force of 200 newtons. So FA is 200 newtons. It does have coefficient of friction, so it does have force of friction, force of gravity, and force of normal. First question asks, what is the normal force? So what is Fn? So Fn, and one more thing, it didn't say, does it say it's going at a constant velocity? No. So I'm assuming that it's going to the right, okay, on a level ground. Okay, every time when you see something on an angle, this is probably the worst thing, is we forgot. We would just say Fn equals Fg. We're so used to that. But don't forget, similar to question 1, when I have a force pulling on an angle, I'm actually changing the force of normal. So I'm going to break this into the xy component so I don't miss anything. So at the bottom here, this is 200 cos of 30. And this is 200 sine of 30. Okay, so to deal with Fn, I'm dealing with the y direction. And let's study how many forces are there along the y direction. So I have the Fn that's going upwards. And then I have the 200 that's going upward, 200 sine of 30 that's going upwards. And then I also have the force of gravity. So 2 going up, 1 going down. I'm going to do my F net equals to MA. My net force in this case is going to be up minus down. Fn adding 200 sine of 30 minus Fg equals to MA. Uh-oh. What's the acceleration along y? If I don't ask that, would you know that you need to ask yourself that question? Would you know that because the acceleration is going to the right? There is no acceleration going up. This is the one that people always miss, okay? Okay, keep in mind, acceleration is only to one direction or sometimes nothing. Okay, you wouldn't have it at both sides. So it's not accelerating going up and down at all. That's why we make it a 0 and we cancel them. So now I can solve for Fn by bringing these guys to the other side. So Fn, bring the Fg over, it becomes positive Fg minus 200 sine of 30. Remember when we pull up, we makes it feels lighter. So mg minus 200 sine of 30. So m, mass is 50, 9.8 minus 200 sine of 30. So I got something like a 390 Newton, and the direction is up. Okay, part B, calculate force of friction. Force of friction equation is mu Fn. I already calculated Fn. So mu is 0.3. Fn is 390. So 117. So I have to round it to 120. And it's going backwards. Part C, what is the horizontal force exerted on the crate by pulling the force? So I actually calculated it already. They want you to know basically what is the x component of Fa. The horizontal force exerted by the pulling force, which is your Fa. So basically they want you to calculate what is the x component of the Fa. I already wrote it out. So part C, Fa along x is F cos theta. And so the F is 200 cosine of 30 sine, cos 30. So 173.205. I know sometimes you're like, how come she sometimes writes it in cyclic and sometimes she doesn't? Because I need to know, and I want to keep as much decimal places as possible. Okay, part D, what is the acceleration? So now I'm studying the forces along the x. Forward minus backward, I only have two forces. I have the x force and I have the force of friction. So I have a to the x. So I have the forward x force, which we calculated, minus the force of friction, and the net force equals to ma. I always start off with that. So I have 173.205. It's whatever that was on my calculator, which is good. Minus, I know I wrote 120. Can you not use 120? Can you use 117 that was on the like that we calculated before? I just don't like to round until we get to the very end. Minus 117. So whatever the thing on my calculator was already that 173, minus 117, and then divided by 50. So the acceleration would work out to be 1.1 meters per second square forward. Keep in mind, forces that are on an angle, you split it into the xy direction. That's number one. Second thing is acceleration always goes at one direction. If it's going to the x, acceleration towards the y is 0. Okay? Okay, two cyclics again. A 70-kilogram hockey player coasts along the ice on steel skate. If the coefficient of friction is 0.0100, what is the force of friction? And then the second one is how long? Oh, how long undo will it take to coast to a stop if he travel at 1 meters per second? So are you seeing that this is a dynamic type of question? We have to find the acceleration and then use the kinematics. Okay, so two-part question. Always start off with free body diagram. Okay, it is coasting. Okay, so he's coasting. That means there is no FA. I don't know if you are seeing that. This is often the problem. People are not seeing that when you're not. It's different. He's speed skating and he's push. Then that one he has an accelerate. I mean a forward force. But right now he doesn't. Right now all he has is the force of friction, force of gravity, and force of normal. Okay, so this one is the one that people often miss. Be like, oh, I'm missing a variable. I don't have FA. Well, but you don't have FA. Okay, so they're asking you what is the force of friction. So I know that the force of friction, I know the equation is FF equals to mu Fn. And I need to use the y direction to figure out what is the Fn. Fn, the acceleration is going this way. Are we okay with that? Like we're accelerating, or if you want, going forward but decelerating, a negative acceleration, and we'll talk about that in a minute. Okay, so along y though, we said that just now, acceleration is going horizontal, meaning there's no acceleration going up and down. So that means I can go up minus down equals to ma, but a is 0. So that means Fn is equals to Fg, which is mg, which is 70 times 9.8. So I got 686. That's what Fn is. And now I can put it into the mu equation. Mu is 0.01 times 686. 6.86. And I told you to assume it to be 2 sig, so I have 6.9 newtons backwards. All right. So part B. Part B is asking you how long, that's my unknown, for him to coast to a stop, meaning V2 is 0. If he is traveling, so the initial velocity is 1. These are all forward, right? I right now have a friction that's going 6.9. Okay, so that means I actually need to figure out what is the acceleration first. So the acceleration is going to be towards the left-hand side, the backward side. Okay, so I still need to do the F net equals to MA. The net force in this case along the X direction, only FF. FF is the only net force. It equals to MA. And I know that the FF is 6.9. The mass is 70. So the acceleration, I have to divide both sides by 70. So I'm actually using 6.86, whatever that was on my calculator, divided by 70, 0.0898 meters per second backwards. Okay, so that becomes part of my given for this question. But just be careful because everything is going forward. I need to know that I have to keep it consistent. So I'm actually going to make it a negative backwards. Forward, sorry. I'm making it a negative forward. So does it make sense that the object is slowing down? So now I have to find the high five that goes with T, V2A, and V1. So V2 is V1 plus A delta T. 0 equals V1 adding negative delta T. Move the 1 over, it becomes minus. Divide both sides by the 0.08, but a negative of it. So now it becomes a positive. If you come up with a time that is a negative, you know you screwed up somewhere. So I got the answer to be 10.2 seconds. Put it in proper signics, 1.0 times 10 to the 1 seconds. So this is tying kinematics with dynamic. So another big thing is when they're saying coasting or it's sliding across the ice, when there's no applied force, don't put a forward force on it. So a washing machine in a wooden crate has a total mass of 100 kilogram. It is dragged across an oak floor by tugging on a rope. So that means pulling at an angle of 30 above the horizontal. What minimum force so it will just start to move? Okay, so I know you guys don't like that. Is the ambiguous. We talked about this before. When I say something just starts, what am I giving you? An extra piece of information when it's just starting. Do you remember what it means? Just quickly draw my picture. The force is being pulled on an angle. This is your FA, and it is 30. And it has FG, it has SFN, and it has friction. Okay, so just starts. Do you remember? We assume that when something just starts to move, acceleration is 0. Okay, so that's the first thing, recognizing the word. Second thing, you see a force on an angle, you break it into component right away. Don't even think about it. Just break it in, put everything in X and Y, make it clean. So this is FA sine of 30. This is FA cos of 30. Okay, study your forces along X, study your forces along Y. Okay, along X, I have forward minus backwards. I only have 2 forces, FA cos 30. FA cos 30. And then minus FF equals to MA, which is 0. Okay, what is FF? I'm going to do it on the side. I know the equation for FF is mu Fn, but I don't have Fn yet. I'm going to have to figure out what is Fn along the Y direction. So I'm going to need these information along Y. And Y, I have up minus down. Up is Fn. Also, up is FA sine 30 minus the down, which is FG, equals MA, which also is a 0. I know I stressed this so many times, but this is something that people don't like to, seems to missed. Okay, so just make sure you remember to do that. So figure out what is Fn. Fn would be putting FG to the other side, it becomes a plus. Putting FA to the other side, it becomes minus. So mg minus FA sine 30. Clean it up. Okay, so this is 980 minus sine 30 is 0.5. So I'm just going to clean this up and say this is 0.5 FA. And I'm going to sub this into the Fn. So it equals to mu, which is 0.5, times the Fn, which is 980 minus 0.5 FA. Expand it out. So you're going to take your 0.5 multiplied by the 480 minus that, right? So 490 minus 0.5 times 0.5, that gives me my 0.25 FA. Now I know what FF is. I can sub it now into this other equation. So FA, I'm going to clean this up first just because there's a negative FF. I thought it would be easier if I just swing my FF to the other side and make it a plus. So FA times cosine of 30 equals to 490 minus 0.25 FA. All right, collect your like terms. This really is just a number, right? So if you want to expand it out, cos 30 is 0.866. So if I clean this out, this one is 0.866 FA. Bring my other FA to the other side. Collect your like terms. I got 0.88 FA, adding 0.25. So I have 1.116 FA is equals to 490. Divide both sides by 1.116. So the answer I got is 439 Newton, and sig digs is really 1. So can you just assume 2 sig digs again? So 440 Newtons. Forward